Examples like this next type here really give people a lot of trouble, students a lot of trouble when they first encounter them. What's going to happen here is we try to do this problem using our substitution method is we're going to find out we actually have more stuff than we need to be able to carry the substitution through. And so the question becomes, how in the world do we handle a problem like this? So you start off, as you standardly would, doing your substitution. Right, allow u to be the inside part of our composite function, and du would call for a 4x dx. And so we then begin to carry our integration through. And as we do that, we have that darn x just hanging around there. So we have our 4 that'll go with our dx. And of course, to do that, we need to have the 1/4 factored out. But then we have this gnawing little x there that just isn't going away. And we say, how in the world do we manage that thing? How do we deal with it? Well, the key is to recognize, well, if u is equal to 4x minus 1, then we can actually solve that equation for x and get that x could be replaced by u plus 1 over 4. Now, what that's ultimately going to mean is we're going to have an integral that's just not going to flow through as nicely as it would have before. But that's okay. But we can still then transform that x now into a u. And that's really the key to being able to do this problem. We have that extra stuff. If we have extra stuff, we can actually sometimes get away with doing it if we can re-express that x in terms of u. And so as we go through here now, we replace the x with that. The 4x minus 1 to the 1/2 becomes u to the 1/2. And the 4x dx becomes du, just like we needed it to. Now the 4 I can pull out of that denominator, make it a 1/16. I still have a square root just like I did before, but unlike before where it was a square root of multiple things and you had a single thing on the outside, now we have a square root of a single thing and the multiple things here on the outside. So this time, using the distributive property, we can multiply through. U to the 1/2 times u would be u to the 3/2. U to the 1/2 times 1 would be u to the 1/2. To go with our du. And now we can carry our substitution through, our integration through. That'll be 1/16 times the quantity. And then we have u to the 3/2, so we'd add 1 to that. That would become u to the 5/2. Divide by 5/2, which is the same as multiplying by 2/5. And then we do the same thing with the 1/2. That'll become 2/3 u to the 3/2. And then that's, of course, plus c. And then we can do some more simplifying. 1/16 times 2/5. The 2 and the 16 will cancel out to get 8. So it'll be 1/8 times 1/5 would be 1/40. And then replacing u with what it is. U is 4x minus 1. That'll be to the 5/2. And then we have 2/3 times 1/16. Again, the 2 and the 16 will cancel. You get an 1/8 times a third. Be 1/24 times that quantity, 4x minus 1, now to the 3/2. And then that's all plus c. Okay, and that's our result. Not nearly as pretty as what you'd expect. For a little challenge with differentiation, you may want to take the derivatives of those two things and see that in the end, the result that you get is actually x times the square root of 4x minus 1. That would be a good practice, doing the derivative with the chain rule and doing some simplifying to see that that does actually simplify to be x times the square root of 4x minus 1. Alright, and there we are. This is sometimes referred to as a change of variables, and it's the one situation that gives people the most trouble with integration by substitution.